In IGCSE or O-level physics, we tell the students that deceleration can also be written as negative acceleration, and in many of the cases they are actually the same. But if we be more precise, deceleration simply means to slow down, and negative acceleration tells you the direction of the acceleration. Now, whenever we talk about the word direction, we need to first come up with a convention. We need to come up with a reference. So the convention is, if you're accelerating, if you're moving, if your acceleration is on the right side, if your acceleration is on the right side, it would be positive. And if your acceleration is on the left side, your acceleration would be called negative acceleration, not deceleration, negative acceleration. If your acceleration is on the left side, whether you're speeding up or slowing down, if your acceleration is on the left side, it would be called as negative acceleration. Similarly, for free fall, for a free falling body, if your acceleration is upward, we call it negative g. If you fall downward, if a body falls downward under the influence of gravity, we consider its acceleration as positive g, which is plus 9.81. For a body moving upward, being thrown upward, its acceleration would be taken minus 9.81 meter per second square. This is a convention. Let's talk about the example A. You have a car, you have a vehicle which is moving to the right side, and the car is speeding up. So if the car is speeding up, the acceleration would be positive. Why? Because if the car is moving in this direction and it is also speeding up, that means the resultant force would be on the right side. Why? Because the resultant force would be on right side because the driving force would be greater than air resistance, and the resultant force would be in the direction of driving force, which is towards the right side, and whatever the direction of resultant force is, the same is the direction of acceleration. Keep it in your mind, you can note it down. Direction of acceleration is calculated from the direction of resultant force. So if you're speeding up, that means your resultant force is towards the right side, in the direction of, in this case, towards the right side, because only then your because your driving force would be greater than air resistance, only then you can speed up. So acceleration is positive because it's towards the right side, and it is acceleration, not deceleration. It is acceleration because the object was speeding up. So because the object is speeding up, we call it acceleration, not deceleration. And because the acceleration was towards the right side, we call it acceleration, not negative acceleration. So let me move on to all of the cases, and then it'll start making more and more sense. When you see all the cases, then you'll know exactly what I'm talking about over here. Let's say here we have another example, and we know this thing. In this thing, I draw this thing, the moving vehicle, and I tell you the object is slowing down. So your car, your vehicle, sees something up front, an obstacle, a barrier, then you need to slow down, and you eventually need to stop. So if you're slowing down, just because you're slowing down, now we call it deceleration, not the acceleration, because you're slowing down. Now the next thing, What is the direction of the acceleration? I told you the direction of acceleration is in the direction of the resultant force. So you have one force which is a driving force forward, and the backward force would be air resistance. If you're slowing down, that means air resistance is greater than the driving force. Hence, the resultant force would be towards the left side. And whatever the resultant force is, the same is the direction of the acceleration. So acceleration is also on the left side. Because the acceleration is on the left side, we call it negative acceleration. And because the object is slowing down, we call it deceleration. So far, whatever we have done so far, that is consistent with the normal cases as well. I mean, deceleration and negative acceleration, they are being apparently they are looking like the same thing. And in the next two examples, we'll be having explicitly the cases where deceleration and acceleration, negative acceleration, they would be actually looking like different things. So let's take a look at this thing. All right, this one, part C, gotta listen to this one very carefully. This is a very important one. So this one, exactly in this one, you'll get to know that the deceleration and negative acceleration will not be the same thing, especially in the last two examples. So the situation is, you have the vehicle which is moving towards the left side and the object is slowing down. Okay, that is given as part of the information, that object is slowing down. So if the object is slowing down, it means it is decelerating. If the object is slowing down, not speeding up, it means it is decelerating. So the object has deceleration. Now the next thing, do we say the object is having deceleration? So can we call the object is having negative acceleration? Well, for that one, for negative acceleration, the acceleration has to be towards the left side. But let's see if the acceleration is towards the left side. So object is slowing down, and the driving force in this case would be towards the right side, because the object is moving towards the driving force would be towards the left side. The air resistance would be towards the right side. Which one of these two would be greater so that the object can slow down? And the answer is air resistance. Only then the object can slow down. So if air resistance is greater, which is towards the right side, then the resultant force would also be towards the right side. So the resultant force would be towards right side, because air resistance is greater than driving force. Only then the object can slow down. And whatever the direction of resultant force is, the same would be the direction of acceleration. So resultant force is on the right side, acceleration is also on the right side, and the acceleration, if it is on the right side, the sign convention is acceleration would be positive. So your acceleration is positive, it is not negative acceleration. So your acceleration is positive because it is on right side. But since the object was slowing down, that's why it has deceleration. So you see, in this one, we can't say since the object is having deceleration, so we can say it is also having negative acceleration. No, acceleration is positive precisely because it's on right side, and it is deceleration precisely because the object is slowing down. So slowing down or speeding up tells you acceleration or deceleration, and what do you call, direction of the acceleration tells you if the acceleration is positive or negative. So here we take a look at the last example. So you have this vehicle, and we say that the object is speeding up. Okay, this is given as the information, object is speeding up. Okay, sometimes all right, now the situation is, if the object is speeding up, then that means the resultant force would be towards the left side. How? Because the driving force would be in this direction, Fd in this direction, air resistance would be opposite, and which of these two forces has to be greater so the object can speed up? Driving force has to be greater than air resistance, only then object can speed up. So the resultant force would be in the direction of the driving force, which is towards the left side. So whatever the direction of resultant force is, the same would be the direction of acceleration, even if it were not given over here. So if the acceleration is towards the left side, we call it negative acceleration, because the acceleration is on the left side. So we call it negative acceleration. But since the object was speeding up, not slowing down, so we call it accelerating. We say the object is accelerating, not decelerating. Why accelerating? Because it is speeding up. But why negative acceleration? Because the direction of the acceleration is towards the left side. Now the other thing is, let's say they have given you the direction of acceleration and they have given you the direction of motion, which is, you can see from here that the direction of motion is towards the left side, the acceleration is also towards the left side. So only this stuff is given. So if these two things are given to you, and let me just raise it from here for a while. So you're given with this information only, just the diagram, given with the diagram only, and the diagram tells you the object is moving to the left side. We can see it from here, object is moving to the left side. The second thing that you know from here is acceleration is towards the left side. Now the question is, with this information given, can you tell, will the object be speeding up or slowing down? And the answer is yes, most definitely we can. We can tell the direction of we can tell if the object would be speeding up or slowing down. How? If the direction of acceleration given is in the direction of the motion. Very important sentence I'm telling, you can note it down as well. If the direction of acceleration given, which in this case you can see the direction of the acceleration given is towards the left side. If the direction of acceleration is in the direction of the motion, then the object speeds up. Let's consider the example C. The direction of the motion is towards the left, but the direction of the acceleration given is towards the right. In that case, the object is slowing down, because the acceleration is opposite to the direction of motion. So they can ask you, they can test you with different ways. Sometimes they can give you the direction of acceleration and you need to figure out if the object would be speeding up or slowing down. Sometimes they will tell you the direction of motion and they will let you know if the object is speeding up or slowing down, and then they will ask you the direction of the acceleration. So the question can be asked in multiple ways.